Dear students, now we are going to discuss about 16-bit subtraction. Okay, so in previous lecture we had discussed about 16-bit addition. Now we are going to discuss about 16-bit subtraction. Okay, so for 16-bit addition as well as for 16-bit subtraction, there is a need of two 16-bit numbers. Okay, in 16-bit addition there is one instruction for direct 16-bit addition, that is DAD instruction. But in the 16-bit data subtraction, there is no instruction for direct subtraction of two 16-bit numbers. So direct addition of two 16-bit numbers is performed with the help of DAD instruction, but that is not possible in 16-bit subtraction, since direct subtraction instruction is not available in 8085 microprocessor for direct 16-bit subtraction. Okay, so you have to follow the logic like you have to subtract lower and lower in both 16-bit data. There is two lower order 8 bits. There you have to subtract that lower order bits and then you have to subtract higher order 8 bits. Okay, so this is the logic you have to follow. Here they have initialized MVI C,00 for borrow, and then LHLD 4500 means the data which is available in this address loaded in L register, and the data which is available in the consecutive address, that is 4501, will be loaded in H register. Then we are exchanging the data in HL register pair with DE register pair. So the first data that we have obtained in HL register is now exchanged with DE register pair. So data, first 16-bit data now moved to DE register pair, and then we are getting second 16-bit data in HL register pair. Okay, second 16-bit data, in second 16-bit data lower 8 bit is available in this 4502, and that is loaded in L register, and higher 8 bit is loaded in H register. Okay, so now move A comma L means the data which is first 16-bit data that is available in DE register pair. Okay, so in this data, here this is available in E and this is available in D. So these together first 16-bit data. Okay, so then this is second 16-bit data. In this 10 is available in L and 8 is available in H. Okay, so now we are going to subtract L and E and D and H separately. Okay, so now we are going to subtract lower order 8 bits and then higher order 8 bits. So L and E going to be subtracted and H and D going to be subtracted. This is the procedure. Okay, so for that now the data lower 8 bits, that is L 10 is available in L register, that is moved to accumulator. Okay, so then we are subtracting sub E means now L is moved. In this data 10 is L. So in this data L contains 10, that is moved to accumulator. Okay, so now accumulator contains 10. Okay, so then sub E means A equal to A minus E. Sub E means A equal to A minus E. So already E register contains 66. Okay, so A equal to A minus E means A contains 10, E contains 66. So 10 minus 66 subtracted, and the result will be stored in accumulator. Okay, so during the execution of this instruction, result will be stored in accumulator. Now that result will be moved to L register. Okay, so then H value is moved to accumulator and that will be subtracted with D register. Okay, so H value, higher order 8 bits, H contains 80, that will be moved to accumulator and then that will be subtracted with D register value. D register contains 33. Okay, so here A equal to A minus D minus borrow. Okay, previous borrow. So here A contains H data, that is 80 and D contains data of D is 33. Okay, so 33 and borrow will be subtracted and the result will be stored in accumulator, and that will be moved to that accumulator result, that is higher order 8 bit subtracted result will be moved to H register, and then the result available in HL will be moved to 4504 and 4505. So subtracted result is lower order subtracted result is available in L register and higher order subtracted result is available in H register. So lower order subtracted result moved to 4504 and higher order subtracted result will be moved to 4505. Okay, so now we are checking for carry. If that is borrow, if borrow is available means we are incrementing C register. If borrow is not available means we are storing borrow result. Okay, we have initialized C register. We have initially cleared C register for storing borrow. If borrow is available means that will be incremented. If not available means the C value will be moved to accumulator, and then from accumulator that will be stored in the specified address 4506. Okay, so then program will get terminated. So this is the program flow of 16-bit subtraction. For 16-bit addition, there is a direct instruction is available for 16-bit addition. Here instruction not available, so lower order and get subtracted, and higher order 8 bits get subtracted, and the result is available in lower order result will be available in L register, and then higher order result is available in H register, and both that will be moved to a specified address 4504 and 4505. We can see the result in that specified address. Then we are checking for borrow. If borrow is available, we are incrementing C register. If borrow is not available, we are going to store the borrow result in specified address 4506. So this is the procedure for 16-bit data addition.